Is the class supposed to be, interactive, or just being and people don't have to write what I'm doing? Because I'm used to training whereby guys are doing what I'm doing. I don't know. How do you want to do it?
Since it's your session, you are the one who should take over and decide on how you're going to present it to the best of your ability. Because since it's your session, you know how to best present it, and you've been training for a while, for a very long time.
Yeah.
So you're the best placed person to decide on how you're going to present.
All right, no problem. Okay. Sharing my screen. All right, you got me?
Yes.
Okay, so all right, that's just a screen I just took yesterday from a tool we are creating to personate APT41 for cyber rages. So for those people who are registering cyber rages, we're soon going to be seeing some very realistic APTs running operations for scenarios. All right, my name is Gichuki. I'm a CEO right now at Onet Group. We do cyber stuff. It can be for cybersecurity or just for cyber. So actually, when you talk about offensive security and offensive cyber, they are two different things, which I hope we will talk about soon as we go on. Thank you for having me today. I don't know if you have so much time. I'll try to be, because of this class, how different it is, I'll have to go slow to get where we get to go. If time doesn't allow us, we might as well continue next week when we get a chance. All right, so from the discussion, I had specified that I'm going to do some of these trainings. I'm hoping that we will get enough time to do it. We will discuss a little bit about red teaming to CNO, and also a little bit of Windows internals, which is actually where you begin for everything you want to do on red teaming, and also for anything to do with computer network defense. Then also for CTI level, it's important to understand the threat actors, and also now when you go to operation level as an operator, you need to learn how to develop infrastructure, that is server development for operations or for operators. Then computer network operations, which is meant for those people who are coming out of a RTO or red team operator, and they want to support government organizations to be able to defend themselves and also to collect intelligence against target they want to look into. Other topics I'd specified I'd like to look into things like digital forensics and incident response. The other is things like threat analysis, adversary pursuit, reverse engineering, and threat hunting. It will depend with time because we have I think we have another like almost 90-something days. So time will come and find a chance to see whether we can actually be able to do that. So these are the steps to CNO. So for those people who want to serve the nation, or want to be defensive contractors, you have to have gone through all these steps. That's why you find computer network operations is actually done by veterans, people who have been there for a while. They have been pen testers, they have been doing red team, they have been doing development, they have been doing blue team stuff. So it all starts from a standard system administrator in a network and support team, and a support guy who is just troubleshooting computers and network. Actually, that's why I started in 1998. Though for me, I was trying to jump over to the other bad ship, which is for black hats. But I think at some point, some things happened to me and I had to change. So it's important that when you are going all the way up, don't do shortcuts like a lot of people try to do. Because what happens is that when you run shortcuts in cyber, what happens is that you become a political guy, and because things become so heavy for you eventually. So it's important to actually go from being a beginner, take your time, learn, develop things, learn how to work in Active Directory, learn how to work with servers, and how to develop subnets and VLANs, and all these other things before you cross over to red team operations. Then you cross over all the way up to CNO. I usually advise young boys and young girls who are coming out of college and who are coming out of universities and college to think of ways they can serve the nation for the next like 10 years. Always give yourself like 10 years to serve your country. And in a way that is important, because right now if you look at the country and you look at other countries, people are trying their best to deal with the cyber insecurity that has been brought up by different nations and different underground, what they call, let's call them bad guys, including terrorist guys, because these days they are developing capabilities for cyber. So it's important to kujitolea at least for a few years, 5 to 10, to help your nation to develop capabilities. So learn, take your time, practice, and then help out. So we discussed a little bit about computer network operations. I'm not going to go deep in this because today the class is not about CNO, but it's important for introduction so that people can understand there's a difference between offensive cyber and offensive cybersecurity or other offensive security. Offensive security mostly is for things like when you're doing penetration testing, or when you're doing things like red team operations or red teaming, or when you're doing things like normal white box and normal black box and normal gray box, because they all help to defend a company or like a network or an infrastructure. So they are part of CND, which is Computer Network Defense, and they help to actively develop capabilities for that organization to have cyber resiliency. Other things that you'll find in CNDs are things like drills, stuff like event hunting, things like CTI, having the capability to have that readiness in case of a beachhead. Things like rapid response or development of SOCs, which are a little bit old school right now, because right now we are moving to things like CDOC. Being able to also run DFIR and also be able to also develop emulation and exploration for red teams. That's what now we call CND. But when you talk about offensive security, we are talking more of capability to collect intelligence on a target, or capabilities to develop ways to collect that intelligence. It could be mostly for signals intelligence, either for military organizations or for intelligence agencies. And that's where we come to things like CNE. Because CNE, you are offensively running and writing applications that are supposed to circumvent security on the other end when you collect that intelligence, maybe for political reasons, maybe for diplomacy reasons, or maybe for the countries. These days they are calling it, how do you call it? I'm forgetting the name. Like for power in a way, when it comes to economics and all those things. So in intelligence community, we call it signals intelligence in transit or at rest. CNA is what happens like now when you talk about things like Petya, or when you talk about WhisperGate or Stuxnet. This is where you gain access to the target you're looking at. Mostly is done by military organizations and intelligence services, but at the same time, defense contractors get contracted to run operations. Like now, I think you guys have seen the latest report about this new group which is working for SVR. Their job is to gain access to normal military network, intelligence service and government networks, and collect intelligence on the infrastructure and its vulnerabilities. They don't do anything else. They just gain access to those networks and figure out ways and means to collect that intel so that GRU or any other offensive operator for Russia can go ahead and now do more impactful collection. I think it is called, what do we call this new team that has come out? Something mole, I'm forgetting. Invisible mole, yeah, invisible mole. Yeah, so, yeah, so, but now when it comes to computer network attack, the actors are penetrated already, and then they do wipe and destruction of data. Ransomware guys, you can say they are also doing CNA in a way, but for them, it's mostly for money it's not about political reasons or any other reasons that governments can do that for. For them, it's more about making sure that the people they encrypt data for, they are not destroying it. What they're doing is just encryption, and they make sure that the user is supposed to pay that. All right, for those who are sending messages, I can't see them because my whole screen is taken. All right, so today we are going to look at a few things on introduction or rather introducing people to all this stuff, so that if you want to go through this path, you know where to start. So we're going to look at a little bit of Windows internals. We're going to look at processes and also Ps for x64 and x86, and also mostly deeper on a little bit. I want to go deeper on private executables, but in the future we might need to look at that because of sections and headers. Then you look at process environment block and also threat environment blocks, and also where we have that initiated by Windows, which is called winterno.h, which is a header. We look a little bit on non-DLLs. Those are DLLs which have what you call PPL, or rather protected process light. For those who have learned about how DLLs are protected in, or other processes are protected in Windows, this would be a favorite topic for you. This is good for those people who want to figure out ways to bypass some restrictions that Windows has. And then if you have time, we'll go a little bit on to loaders, and we talk about that because this when it starts, if you are able to understand all the Windows internals, then maybe you can write a little bit of loaders, then you go all the way. Because in operation level, when offensive operations are being done, it starts from maybe from a dropper, downloader, loader, because obviously by default these days, loaders have the capability to download and drop and execute. But sometimes it's good to know that all those steps go together. So after the loader, you have you'll have maybe a stage 1 loader, and then a stage 2 loader, and then maybe as the operation goes on, you might bring in a stage 1 implant, and maybe a stage 2 implant, depending on how what type of targeting you're doing on an infrastructure. And that's what adversaries do. They build those capabilities so that, especially high-tech, those guys who don't want to be found, they want to finish their objective, they will make sure that they build an infrastructure that has capability to hide itself and toolkits that will have capability to hide themselves. And as usual, we always say, cyber deterrence creates a next decade's malware problem. That's true. Every time you see some new technology coming up to defend an organization, someone is always coming away to figure out how to bypass it. And that's how it goes. So let's get to it. If you have any questions, maybe I can check right now to see whether I can answer them. Any questions? Or short code names, like which ones? CNO, computer network operations. TA is threat analysis. DFIR is digital forensics and incident response. AP is adversary pursuit. Which one else did you get lost on? Yeah.
No. What I was saying is.
Go ahead.
Hello.
Yeah.
What I was saying is, for now, newbies, guys who are starting out, okay, like we might assume that everyone is conversant with these terms, but yep. I'm also asking is, if there are newbies in here, when you're trying to expound on maybe a short code, just try and say the full name and then now say this is the code that we'll be using, so that if someone is writing notes, we'll be able to understand from there.
All right, copy that. So we usually call them acronyms because cyber, anything with computers is what do you call it? It came from military. So most of the things that we use on computers, like ping is a short name, also an acronym. Everything is supposed to be usually acronyms. So we kind of go on with that. So, but I think if there is any word that you found that I haven't said properly, because I think I said all of them, unless maybe you were not there when I was doing it.
No, for me it's okay. But I was just saying for maybe there are new guys who might not know these things, because
Okay.
when I started, maybe I never knew these things. But
Okay. Yeah.
once I learned them, it was okay. But for new guys, they're usually afraid of talking. So I'm just here to maybe help them so that they can be able to understand these things.
Okay. All right. So,
Yeah.
any other question before we continue now to from because I don't want to kill people with PPTs or other, they're called what? Presentation killing up. I forgot how you used to say it. All right, so I'm going to go back to my screen. And I'm hoping everyone has a Windows machine, because today we are going to mostly look at Windows machines, and we are going to figure out a few ways of dealing with that, because mostly it's for Windows. Sorry. Let's see. I'm going to log into another box, another Mac box here. Am I sharing my whole desk? Yeah, awesome. I'm going to log into another box here, which I use for sometimes when I'm training. And it has virtual machines on it. So what I want to do is pick up the IP address of the virtual machine that's running there. I've just booted it up, so most likely it's still loading up. No, actually had it running. Yeah, so let me pick up the IP address so that you can use remote desktop. It's 109. All right, 109. So 109. All right, 109. Good. Dev tester. Supposed to be this. So edit 109. All right, so what was the username? All right, so where do I put the credentials? Oh, here it is. All right. Oh, these are three machine actually. Let's see if I can connect to it. All right, we got it. So I'm just going to go there. No. Wait a minute. Okay. It is. Let's see. All right, we got it. All right, so it's a Windows box, and we are going to go to a little bit of Windows internals so that we can work out our way up and play around with some of these things. So I know time is against us. Let's do what we can. We can always continue next time. So as usual, we all know how Windows works. So I'm just going to go all the way to the normal things that we are going to be working with right now. So we will start with the processes all the way to PEs. So by default, I'm going to start process hacker, which will tell us more about the processes that are running on the box. So let's take us an example of the CMD that you're already running here. It's active, and if you look at it at the processes, you look at the properties of this process, you can always double click. You can see the modules which start with the CMD, which takes us to the emulator processor. Then the DLL that's being used now to bring the COM object and other COM stuff into the process. Then you have other DLLs, which are like kernel.2 DLL, kernel-based.dll, and other applications or other DLLs and other PEs that might be used. So if you look at this being a .exe means it's executable. which means by default, because it's an executable, it means it's a portable executable. So if you actually look at the properties, we can see it's an application system. It's an application software. It's inside Windows Systemplus 2, and inside C Windows Systemplus 2 means that the application is x64. I can go to the Windows folder so they can actually be able to understand what I mean. Windows system, wow. So this is where we have 32-bit applications. And Systemplus 2, this is where we have x64 applications for Windows. So like now, if I go to a system wow 64, if I'm fast, please let me know. It's because I'm wondering if maybe, because most of the trainings I usually do, I usually expect the user to, the trainee to actually do what I'm doing so that they don't get lost. So anyway, if I go to an API like API, yeah.
Kenneth, you have, don't worry, you have enough time, and the whole of next week will be yours to take charge. So you can take your time. I can't do it so that everybody can follow.
I can't do much of next week because of work. I have so much on my plate.
Don't worry, we'll reschedule next week's training for a later date when you're free. But you have enough time, and we'll take as much time as possible for everyone to get whatever you're teaching.
All right.
So don't worry about time issues. All
right. I'll be stopping after every 20 minutes or so, so that I can have questions asked. Yeah, that's okay with them?
Okay.
All right, so like now, if you go to System wow 64, this is where you have x86 or other 2-bit applications. So like now, if I go to properties, you see this application or those software and stuff like that. And if you go to details, all that information is there for you, and actually you can see it's actually signed by Microsoft, all that stuff. But here is where we have x86 applications. But now, if you look at this, it is already inside Systemplus 2. But so if you go to System wow, and you run the CMD that is here. So where is it? Because obviously there must be that 2-bit CMD. By default, it should be there. All right, go. Oh, here it is. Almost what I call there. I usually change a lot of things, Windows all the time. So right now, if I go to the ones for System wow, and I go to Properties, and I go to General, you can see it's about a 2-bit version, right? But you go to the other one we had before. I think this is the one, right? No. Yeah, this one. If you go to the older one, you'll notice it's a 64-bit version, which actually tells us all the files in this folder are the 2-bit versions, and all the files on Systemplus 2, all the PE files on Systemplus 2 are what you call 64-bit versions. So by default, bad guys usually interact between these two folders, and this is what we call Hijacking. That's a different topic altogether. I'll not talk about Hijacking today, because that requires at least some mode of deeper programming capability. All right, so so if you go on checking through the threads, you see there is a folder here with information about the threads, which gives you the TIB, or rather the thread information stuff. And look at the tokens. The tokens that this CMD or this file has when it's running as an image. We already talked about the modules. The memory also, it gives information about the shared data, the PEB, the heap, all that information. And you can actually be able to see this, tells you is only readable, or this is readable, writable, all that stuff. So these are things actually we are going to talk about later on, because you can look at all these files, this stuff inside, because these are some of the things we usually do when you're doing reverse engineering on files which are really packed. So you open it with EDA or a debugger, because by default most likely to be blocking things like x64 DBG or like DBG or the debugger. But sometimes with EDA you can run directly on debugger, and then you just open up the process from here and collect the exes which are hidden, especially if they are packed inside. I'm going to talk about all that stuff later on. I hope you have time to do that. Then you have the environment. It gives you all this information about the set of the command. Usually you can actually get this information by doing the command like set. which will give you more information about the environment, or rather, environment for that process, or rather, environment for the computer. So, like, if you look at program data, which is used by a lot of different hackers to go in to actually drop stuff, especially in Kenya. Like now, if you go to program, you can do program data like this, and it'll take you to that folder, right? So, which has the program data. So, those are just some of the things that set helps you with. All right. So, PEs. So, we have seen that each process is actually spawned by a PE. So, let's go and look at those PEs. So, like an example, if you go look at the 2-bit CMD, all right, looks like I got a scroll until there. Let's say CMD. Let's just do CMD. Let's not open another one. All right. So if you look at CMD and you install a software called Cff Explorer, for those who have not installed, don't have Cff Explorer, you can always go get it. So Cff Explorer, it comes with a suite of tools. You can always actually hear it because every machine I install has to have Cff Explorer. You can always download it from this suite. It's a very good tool for analyzing portable executables, and I would recommend that anyone who is in the class to actually install it so that you can understand, so that don't get lost in the future classes and get to understand some of the things. So I'm going to open CMD with Cff Explorer because it's a portable executable, and you'll notice a few things on it. One of them, where it begins, or where the file begins, is what you call a DOS header, which starts in an eMagic file, which is 5A4D. 5A4D is what you call the MZ. So the MZ. This MZ comes from a name of one of the programmers of Windows DOS. He has a name which is Slavic. I keep forgetting it every time. I don't know why. I've never memorized that name. I should memorize it because every time when I'm training, I black out, right? Because I can't remember the name of that guy. It's Slavic, and it's a nice name though. So 5A4D is MZ. We are going to get to that, and you're going to get to understand what I mean by this, because you're going to look at it on programming level. Because when you are working with the assembly, it gets taken routes with grams 4D, 5A, which is a discussion we're going to talk about later. And then also here is an offset, which is the 3C, which now takes you to the NT headers. And this is where you have what you call the file headers, the NT headers, and then the section headers for the PE. All right, so 20 minutes are over. In case of any questions, let me pause there. 2 minutes or 3 minutes for questions. Any question? We are all together. We continue. I want to go now to PE stuff.
Chat, just to interrupt a little bit.
Yep.
There are questions on the message board, the chat.
All right, copy that. Hang on, let me get there. All right, so yes, Kevin. Yeah, so 64-bit, the PEs on the files we're going to find in Systemplus. That's for Kevin, Yugi, Katrina, Lois. Fast, so sorry. I'll try to become a little bit slower. I'm used to training classes whereby the trainees have their laptops open and the computers open, and they have access to servers, and whatever I type, they type. Now, I don't know if this class is like that. I would hope it is like that. So if it's actually like that, let me know so that I can wait for you to type, and I type, you type. Yes, yeah, so there are those things which I cannot go deep into, but I can mention them because it's supposed to be an introductory class, and I'm hoping that I don't lose people in it. Because this is not a normal class whereby I train like a 2 months class for every day. Yeah. All right, a DLL is a dynamic link library. We'll get to that. Just hang on there. It's a dynamic link library, and we get to all that stuff. Just hang on. We discuss the P's and the C's and all those stuff. Any other question before we go on? All right, we go on. All right, so everyone wait for another 20 minutes. Yeah, what? Nope. Kevin, I'm waiting for you to sing something. Kevin, are you?
No, I'm okay.
All right.
You can continue.
Okay. All right, everyone. Sharing my screen back on. All right, so so we talk about the P's. We have P is like this whole structure is like a book in a way. That's what I usually hear people say. I don't know. It's kind of a way in a way because it has all this information about a product executable. So it will have the dose header, which already started 5A4D. When you're dealing it with assembly, when you're writing on the assembly, it comes for D5A because you can it. That's a little bit of ideality, which we'll talk about if you get a chance when you go deeper into assembly. Then from headers, we go to sections, and this is where you have stuff like text, data, p-data, all the resources and the locations for that PE. So sometimes you'll find bad guys, what they do when they're packing a PE, they will write code in a way that using things like virtual, and they'll create a section here, let's say call it data. And inside that data, this is where they are going to store another PE. So they'll add another PE or another build other stuff and build another PE so that when the executable drops on the machine, it will unpack itself and execute inside the DLL. I mean the DLL or the EXE or another PE that will be here, and run it on the background. So those are some of the things we might work with. All right, I think I need to stop my messages all of them. All right, let me stop my signal and my Teams. Some so that I don't get the calls or messages coming in. All right. So let's look at the PEs which are there, like DLLs, and see how they look like. This one actually tells you it's a 64-bit. So if you go to, like we say, if you go to system wow, you'll have the same information on the same executable. So if you go to like a system out, which actually contains the 2-bit versions of those PEs, you'll have the same ordeal rather. So same Cf Explorer, and you have the same information about the 2-bit versions. All right, so all right, so other files that actually PEs are DLLs. So like let's say CMD external or other extension. So if you go to, you open it on CFF again, you'll notice also it's a product executable on that 2-bit version because it's system wow, and it has the same things and the same what do you call it, offsets, all that stuff. So when you go look into PED, you'll notice that the offsets for the 2-bit versions of PEs and x64 versions, they have different offsets when it comes to reading where the memory is. The pointer for maybe a PEB or LDR, which we're going to talk about in a few minutes. All right, so that is done. So I'm not going to say anything of that. So download the Cff Explorer and enjoy a few things of that. So inside here is where we have this DLL, some of these DLLs, or rather even on Systemplus 2. And some of these DLLs are protected by Microsoft, but these DLLs are actually called known DLLs. So one of the best way to understand Windows internals is going to MSDN and looking for known DLLs. I usually write them like that, known DLLs. Let me if we have good documentation. Yeah. So there's a documentation here which you can actually look at, which specifies about known DLLs. And those known DLLs are DLLs which are actually protected by Windows, and they're used by Windows internals and stuff. So for you to understand known DLLs, it's important to actually go and read up what you call PPL. So MSDN, as usual, as I said, MSDN is very, very important. So protected. Let's see, it will come up. Okay, even Kaspersky, I've written a little bit about that. And here we go. Let's use MSDN instead. And in MSDN, they actually have come up with all that information for you, which tells you about how Microsoft protects its processes using PPL and stuff. So this is another blog or another entry in MSDN which you need to look at so you can understand some of these things that you might need to know and learn when you're doing offensive cyber or when you're doing offensive security for defense. All right, so what else have we forgotten about PEs? So for those classes we're going to do in the future, or those classes we're going to work with when you're developing capabilities, we are going to learn more about how to work with sections and the headers when you are passing a DLL, or when you're passing an exe, maybe when you're developing a packer, or when you are doing things like injections and stuff. Or actually, if you look at like how Cobra Strike runs, before it drops a DLL, it passes through, if you go through the source code, which is going to be another class, we go through the source code of Cobra Strike. When you dump it from the jar file, you notice how it actually does some of those steps. All right, so yeah, any questions? I think that's like 10 minutes out. Any questions? Nothing? All right, let's continue. So how do you make a Windows DXE on Windows? Or how do you develop one, and how do you work with that? So in the classes, we are going to work with Visual Studio 2019, and also we are going to be working with the other open source version, which is called Visual Studio Code. And let me close this thing so that we solve, because I'm using a virtual box. Do you have any other thing you need to close? Yeah, let's just close this. This is on a 2D. And Visual Studio is one of the applications that a lot of guys who write code for offensive usually use it, because it can use both C and C++ together. And you can work on with .NET, and you can work with C#. And the good thing about working with this is also that we can actually put ESM stuff in it, whether MASM or no more ESM calls. And these are very good because you are going on low level, and you're working with shell code. You also work with things like system enter. This is where now you go directly to the kernel. And that's one of the aspects that you will find a lot of guys who write some of the best tools in C and C++ and assembly. They are going to use Visual Studio from Microsoft because of how it actually interacts with NT API and Windows API. And Windows API is one of the subjects we actually need to work on. And so let's open the solution. It has nothing on it, I think. I think it was supposed to be a test solution. So to work with Windows, you'll need to install some stuff that come with the Windows, which is called the SDK and also the .NET module. So let's get that. How many we just used to open? It's one. Then I don't know why it's slow. Any options? Everything is set there. All right, extensions. I think it's manage. Where is it? Oh yeah, get tools and features. So when you install Visual Studio, For Windows, you need to make sure that you have a few things installed so they can actually be able to work with SDK. You can actually be able to work with .NET, all that stuff. Am I on the right button? Yeah. So here's where you make sure that you install the stuff you might need. So .NET development stuff for C, the normal ones is like things like CMake and stuff. And the other things you need to make sure you install are things like Windows 10 SDK. You can always install the latest one because it has some of the latest functions and stuff. You can also install the older versions of Universal Platform tools. These ones help when you're writing tools that might need also to do attacks on Windows XP and below. And that's important for some of those targets that might require, that might have, or that will be using some of those applications, or rather, all those operating systems. I'm not going to update anything, so cancel that. Yeah, so I'm hoping no questions so far. So right now what we're going to do is that we're going to make just a simple executable. And to do that, I'm going to open a new Visual Studio. And what I want to introduce you to is how you actually create some of these things. Make sure you have installed the stuff I've already shown there. And to download Visual Studio, you can always go and do MSDN download Visual Studio community, I think.
Let's use Visual Studio community.
There's some noise somewhere. All right, Visual Studio community, and if you go to downloads, I think you should have both versions, this version here and this version you're using right now. And you can download community, and you'll have access to Windows SDK. So to create a Systemplus project, you go to create new project. And here you specify an empty C++ project. So that's what I'm going to do, which is this one. And what you're going to do is something I usually show the beginners for each class is like, you want to see where that file that's executing is running from. To do that, we usually use a module for Windows API, which is called get module file name. So to actually look at APIs for Windows, you can always do the same thing I'm doing in MSDN. So MSDN get module file name, let's say like A or W, I don't know which one they are going to allow me to use C. And you can see it actually tells you something about a header. So by default, when you install SDK or Windows API or those Windows SDK files, you'll get a place where the headers are set. So by default, if you want to see them, you can go to, let's say, the x64 version of command line tools for Visual Studio. By that, you can do x64 native, and it will give you the command line aspect for Visual Studio. Let's try the x64 version. And when you get there, it will load up the command line for x64 version for Windows Visual Studio. And you can do the command set, and it will show you all the set variables for this environment. And what you want to go look into is a folder called the folder. This folder is one that has all the includes all those Visual Studio Windows Kit headers. So I want to go just there, and so that you can see some of those headers. And if I dir, you can see all of them there. And the one we want to look at is this one. So if we do dir and we do file str, and think we just look for every capital and small letters, you can see that you have the header here. So actually, if you want to open, you can always open a notepad or anything you want to use. For now, just do type or type, and I can open it up. All right, so it has all the detailed information on how to use get module file name. So it explains to you how you retrieve the full qualified path of file that contains a specified module. The module must have been loaded by the current process. So this is what you're going to try to do and see whether we can actually be able to see the whole path of what you want to do, want to execute. This is a very nice way to learn how to use Windows API on C++. So what I'm going to do is that I'm going to say get path for execution. So by default, Windows Visual Studio will always store your files on the username that you're actually running with at that time, then a folder called source, then a folder called repos. So you go ahead and make your solution. So great. All right. So as it loads up, you can go through this. It gives you the parameters that you're going to use to actually work the function. So down below, it will tell you whether you are going to import a library, and you can see it's importing a library called kernel32. This kernel32 is also what you know as a known DLL, or rather a known dynamic link. So how do you know which known DLLs you have on your system? All right, Microsoft came up with a software called Win Object. So you can do msdn to download it. I don't know if I've downloaded it. msdn download Win Object. I may have to download both of them. They're actually part of Windows system internals. I may have to download all of them, the 64-bit and also the 2-bit. It is, I don't think it is that 2-bit version. Let's get it in there. Yep, save it. It looks like this one has loaded. We have 2 of them. We need to close the one we're not using. All right. And this one has come down. So let's go look at Windows objects. So download folder, and we open this up. And oh yeah, we can use any that you want to use. So I'm just going to copy these ones to my downloads folder. Well, let's just use download folder. This is a system for just training and stuff. All right, to see them, you can always double click to just log in as a normal user, or just load it up as an administrator so you can see everything you want to look at. And if you have looked at what's Whispergate, Whispergate has a lot of COM object information that actually goes to the physical hard drive. So what we will look at is the DLLs, the known DLLs that are from 64-bit, which are these ones. And this is a list for all known DLLs that are signed by Microsoft, and they have that restriction for PPL. So when you go to PPL later on, when you're doing things like bypassing on EMSI, or when you're looking at things like zone identifier, when you download a DLL from the field, these are going to be very important files for us to look into. And one thing is that these ones usually load a lot of information when Windows loads up, and they usually are used for a lot of stuff. Like now, if you look at GDI, this is one that's loading the screen, the bitmaps, all that stuff. And one of the best ways to learn about these DLLs, if you do research, like I usually just take time, like I can go to IDA and just open kernel2 just to see a few things which I'm not looking into. And the amazing thing is that every time you do that, you always you'll always see a new Windows API function that you didn't know about, and you can go read it up. And the funny thing is that those Windows API functions that are not documented well by Microsoft are usually the best one to look at. Yeah, secret. So if you want to be able to do some of the crazy stuff on Windows, go read those Windows API functions that are not documented also. Yeah, so you can download the Windows object software, and it will give you a lot of information, drivers, devices, all this information that actually objects files to. It's also very important for you to understand COM, and in COM is where you get a lot of good stuff, which we'll discuss maybe in the course of the month. All right, so let's close this up, and let's go and do some coding. come on. So as usual, we have seen that these files usually have this is where you have the headers by default. But Windows usually has all of them, maybe in some single files like windows.h. One of the best way to note that is to go to where you have the get module, and it will tell you this header is actually included in this Windows header. So you don't have to just use this. You can always use this when you're writing your code, right? So by default, when you do that, you go ahead and do, you add a new C file, new item, and we give it a name. And the name you're going to call it, what are you calling our solution? Get path.exe. Okay. Get path for exe. You can always call it anything else, anything you wanna, and it will still work with you. So your application, your code is there now, so you can actually be able now to work with it, and this is where you do editing. So what I'm going to do is I'm going to make my fonts a little bit bigger. I don't know if anyone's having issues with fonts there. I know most of us, we are blind as bats because of staying on the computer 24/7. I'm going to give it maybe 15. And I'm going to expand this a little bit like that. And I'm going to do the first initial include, which is now the include that we just talked about, which is windows.h. Let me know if you can see so that we can continue with that font. People with glasses, can you see whether you can see that? Or there are questions. Actually, it's already 20 minutes past. So let's pause and go for the font is good, eh?
Yeah.
All right, so questions. All right, so as I say, the DLL is a dynamic library, a dynamic link library. By default, it's usually attached to a process. So we're going to discuss a little bit about DLLs when you go to DLLs. Now let's work with an exe. Even if I'm going fast, it's okay to ask questions. Just wait for the 20 minutes, and I'll come back to your question. Because most of the time you might have the video done, and then you might not be able to know something, and then you ask yourself, now who will I ask this? All right. I think there is no other question about what you're doing. All right. Let's go back in. I hope I'm not so fast. I hope I'm not jumping stuff, because I'm known to jump stuff, thinking that people know what I'm jumping, and I end up losing everyone else. So in case you get lost, please do let me know. All right. So so Windows include now helps you to work with all the other functions that are included on Windows API. So by default now we can actually be able to not just do main. We can work with winmain, which is the main, winmain. So actually, if you go to MSDN and specify, like, let's just hold this one, don't need anymore. We go ahead and say MSDN, I think it's supposed to be exe, I think. No, just do MSDN and winmain. This is part of WinBase, which means WinBase is another included header by Windows API. So if you go down there, you'll notice it tells us it has included in Windows H, Windows header. And the good thing about this one is that it's the entry point for graphical Windows-based application. If you actually look at applications that are written by very good guys who do offensive, let's say an example of Carbonac. You have, can I search from GitHub? Carbonac. So some of the tools you should go and read up. So if you learn how to write code, just go to these tools and read how these guys were writing these tools. And if you learn how to write like this, there's no network which can be able to stop you. So let's say a downloader for Carbonac. So source. main. Yeah, they're including a lot of headers that they have already have on their machines. And the entry point, this is a Windows executable. It's not a DLL. It's supposed to be win main. So you see win main, the entry. Oh, this is actually joined into the whole. I think it is joined into the whole application. So they have a lot of static in it. So yeah. Come on. Sometimes I usually just spend on GitHub to just read code. That's how sometimes my nights end. All right, let's look at service BP. Maybe service BP is the one that's going to have. No, service is supposed to be a service. Let's look at something that is going to be exactly what you're looking for. And as you can see, it's written in Visual Studio. That's why it has extension SLM. And the same thing we have here. So if I go to where we have the folder of what you're writing for our source code, developer supposed to be on source repos. Get path for XC, you can see it has a SLM. Sorry, it's all fractured here, and I don't know what happened. All right. So so let's look at least one of them, like the bot, which is supposed to be the implant. Let's go to the source, and this is the AV bypass. I don't know if this is the right. Yeah, let's go to main. Let's see how main looks like. I'm not logged in with my GitHub, so I can search. Main. Oh, this is a DLL actually, so it takes you to. Yeah, this is a DLL. So also DLL is have to be DLL entry. Yeah. A break?
Int main is defined as the first function just below the variable declarations. Just go upwards.
Yeah.
Int main.
It's there on the bot?
Yeah, the first function just after the declarations after the header files.
All right, let's go get it.
At the top of the code. Yeah, that one.
No, I'm not talking about this one. This one is for console. When you're writing console applications, you can use win main. When you're writing Windows applications, that's also supposed to spawn a window. You use win main. So okay. I can't find it. That's why you're seeing here we have DLL entry. So it looks like this, but it's for entry is for Win API or even API entry. Or a different SDD call. We're going to talk about SDD calls on a later end when you start looking into deeper C. This is being a DLL. Let's go back and look for something which is not a DLL. Is a keylogger, was a keylogger an executable, an exe? Well, this was hooked directly into the main functions, I think. In a hot, I looked at Kalbanak. All right, so anyway, this is how you actually go through GitHub. So most of the people usually just download software and then use them for attacks. Don't do that. Learn what's written there by the bad guys so that you can actually be able to develop better tools for your operations. So let's try and make our first application using Windows API and see how it will function and how it looks like. So today we are just going to, because of time, I think today we just do .exe. Next time we can do DLLs and then we go ahead and go all the way to the loaders because we don't have, I don't know if we have enough time to do everything. But I had already planned the class to go all the way to process environment block and TEB so that next class we can do loaders. I can do instruction loaders and then I can specify you work with a dropper, downloader, loader, stage 1 loader, stage 2 loader, or even stage 1 and stage 2 implants. So I hope we'll get to that point in a way. So obviously an entry point is going to be the Win API, Win main. So by default, if you come and check out how main looks like, so let's just go and do that. It's important to actually make sure that we are doing the right thing by looking at what is, although by now, if you have written out of main applications, you can always remember what it's here. But because of learning purposes, it's important for us to look into what H instant is, which is a handle, and the next handle, which is instant also for the previous part of the application. And then you have the local pointer string, which has the commands that might be used, or rather CND which will be used. And then you have the show, controls how the window is supposed to be shown when it executes. So let's go do that. So we can call this H module or H instance. You just use H module for now. Then you give it the current. It's actually the current name, the current one you're using, or rather, of course, car. The other one is the previous one, I think. Yep. Previous. So let's go and do the previous also here. You can call it prev, because I like giving them short names. Yeah, prev. And the other one is supposed to be a local pointer string, which specifies how the commands are supposed to be executed. So lp_str, and we give it cmd. And then this one is supposed to be the show, so it's supposed to be an integer. It showcases how the window is supposed to be open. And here is where now we open how the function is supposed to work with us. So by default, we're supposed to return a 0, right? So in C, what did I do wrong? Oh, okay. All right, in C, whenever we are writing functions, we do function. So I'm hoping that people have done this. So I'm not going to go deep in this. You do like that. Whenever you do a comment, it's like that. Whenever you, what else can you do? When you do a large block of comment, it's like that. So like that. So those are things that it's important to actually learn and work with. And the other thing which is very, very important is to learn how to work with pointers. I know some people here who are now studying pointers. I know you're dreaming with them. When I was doing pointers, I was dreaming with them chasing me. So pointer to pointer. So it's a crazy world, this type of stuff. All right, so now what we want to do is we want to be able to see the path. And the best way to see the path is that because this is not a console application, we want to see the window pop-up so that we can actually be in a position to see it. So to do that, we might need to use message box. So as usual, because right now we're just using a version, which is for Unicode. We're not going to go all the way to, so not Unicode, okay, I remember, I'll let you know. Message box. A. So by default, as I say, a function is how a function opens up and you close it. So let's go and look at how message box is built. So msdn. As usual, always make sure msdn is the right place to go in if you are writing stuff that has some good stuff for you. Sorry, it's supposed to be message box, this one, not shell message box. This displays a model dialog box, like the dialog box you see, the usual message box by default. Then it actually gives you the options how to actually work with it. So you have the what you call the handle for the window, the local pointer constant string. This is supposed to be like a display of something. Then you have another local pointer constant string, which actually gives you dialogs for the box. And then you have the content of the behavior of the dialog box and how the parameter is supposed to put so that you can actually be able to cancel or yes or rather whatever you want to use. And each you can see here, they actually specified. There's MB, there's about and try and ignore, which you actually seen a lot of Windows boxes whenever they do that. All right, whenever you close up a window. So if you go on down, it gives more information, but what you want to look at is the DLL that is being hooked here or being used here by this function and also the header. So by default, the header is supposed to be Windows user header, and it will also be inside Windows.h, which means we don't have to include it again. And the library is user32 library. So if you actually go, as an example, if you actually go to EDA and actually look at user DLL, user.2DLL, notice that all those functions are actually there. So some of the functions are documented are there, and some of the functions are already there. So new user DLL, user.2. You don't have to pay for EDA to actually be able to use it. You can use this normal simple one. The normal one that you usually give out for the community. So as issue to actually tell you is a product server, like just what we were discussing before. You click OK and it will load for you the whole thing, and also to ask you for the PB. This is something actually I needed to talk to you about, but time went against me. This is where you have the program database, and this is how you catch information about like if you're actually analyzing a malware and people forgot to remove their PDB, you can tell how it was compiled and who compiled it and their path names and that stuff. So that will come later when you compile our software to see the path. All right, so it loads up the database for the file, then it compiles it, and then what? All right, and this is what I was talking about, the imports. So if you look at these imports, you can see that we have all these APIs, Windows APIs, and the one you're working with is called the message box API. Okay, it's still propagating. All righty, good. What the hell is it? And I think these are these ones which are called the NTs. These are the ones which go all the way to the kernel. When you go deeper into computer network operations and red team, we'll discuss about this stuff, which is very nice to actually learn. And I'll be pleased to show it up. I don't know why I can't see message box here. That's weird. It's supposed to be there. That's so weird. It's supposed to be there. What did I open? Also that to do here. Yeah, it's supposed to be there. I don't know why I can't see it, but by default, it should be there. It should actually be showing you all that stuff. It should be showing the function there because it's part of user DLL. But by default, you might also see it on kernel that is too, and also kernel base. It might also be there. Anyway, this is the way we actually look at libraries to play around with them and to understand some of those things that you might use to get some non-desired activities done on a target box. All right, don't save. So to work with the message box, so I'm going to go ahead and now write the line for message box. So it will need the window, it will need a text and a caption and a type, which is going to be an unsigned unt. So let's go ahead and do that. So we call this now. Just give this now. That's supposed to be the handle to the window. The local pointer is going to be message test. And the other is going to be I tested. And then here we go ahead and do the boxes. So let's look at something like cancel try continue. So it's going to be MB cancel try continue. So by default, this should give us a box which has this option and also this message here and all that stuff, so that we can actually be able to play around with it. So if you try to build, it's going to be an error because the entry point is thinking that you're running what you call a Windows console application, and mostly we are actually working with a Windows console application. We're working with a Windows API, so Windows application. So the subsystem is supposed to be Windows application. And you can see it failed, and it gives you that option for the YACS. This is going to be a very important error for us in the future to understand how we have not resolved the internal information. So to do that, you go to the project, and you go to project properties. And on the project properties, obviously it's an exe, so this is where you change your stuff. You're writing a DLL, if you're writing a lib, you're writing another things like a makefile, a DLL, I mean a driver, all those things. So those are places that you change. Also, because you're running a 2-bit version, it's important to make sure that we specify the configuration you're going to change are going to be for that 2-bit or rather x86 version of the applications. So if you change anything here, you change how you're going to work with it on the debugger level, because this is where the project properties are. So on this part of general, you can do this, but it's not an important part right now because you're not writing anything heavy. Also, this you can remove because you're not writing, but anyway, you're not writing anything heavy. Right now, what you want to do is mostly work on the linker code. This is where we have this error of unresolved internals. And this is where we go to system and we change the subsystem to Windows and we apply and we say, okay. So right now we can compile. And there we have it. So if you go look at it, so let's say we go to open folder in Windows. You can go to debug because you're working with debug. And you go to debug, you'll find that your Explorer here. And you can run it by doing cmd from here. And it take you directly to where the file is. And you can do get path.exe. And it will execute and tell you this is I tested as the topic on top here, or the caption, and then the message, and then it will give you the buttons that you need to work with. So now what you want to do is you want to give it information like, where did this file run from? So let's just cancel that. And use the get file name function. I think I've done it here, so I'll just copy paste it just to make sure I don't make any mistakes. The extended version is this one, but for now, because of learning process, we are going to use just the normal SANI version. So to work with the function, you can always go ahead and name it there, and then put the stuff to show it's a function. And the first entry, as you can tell, is the H module. So the H module is by now added to the loaded module whose part is being requested. Is the parameters now? Yeah, so it's just now. So let's just go and do now here. The next one is the local pointer string. This is where it's going to tell us where the path is. So by default, we need to make sure we build a char file, because you can see here it is a char, if I'm not wrong, the local pointer file name. It's a string, so we give it a char, which is for other places in the country to collect cars. So car, or char, and we can say where, and we give it a max path name. So max path, so it can actually be able to run for the whole path plus another byte on top of it, so +1. So by default, we should have now that as our local pointer string. So what we're going to do now is to specify that here. So we're going to go ahead and say where. This is where the path of the module is running from. And the last one, what? No, capital. Amazing. These are the mistakes we make, and then you sleep here forever trying to figure out where we went wrong. All right, so the next is the dig word to the size. So how do you specify it? The size of the file name. This is the size of what the file name is. So it's supposed to be the size of where. So size of where. All right, so save that, and have we done it properly? Max path is one, where, bum, bum, bum. So right now we have not specified where it's being run as a test, but this is where we are going to put it. So where we will run it from. All right. Save it. Let's build it. And let's go ahead and walk through it. So CMD, get path. And now you can tell that we actually know where now we are going to put the stuff required. So let's just go and do that and make sure that we call the command, the function, or rather, we call the string that was already specified as the max path, and we call it here. So cancel. Where? Where? Awesome. So now if we save and we compile, all right, let's check out the email again. I closed it. Now you can see that it's actually telling us the path of where the executable is. So this is just a simple way of actually how operators will actually use a function to get to a file on a box. And this is a very good way of practicing. Actually, I should give you this small examination from whenever we actually deploying new guys. They come up with ways and means to play around with this stuff so that they can be functional when we start running operations. So the other thing is that if you want to debug and see how the files are, the functions are being called, we can always use the message box. I mean the debugger, or rather, what do you call them here? The breakpoints, and you can run it. You can run the debugger directly, and obviously by default, because it's a PE, the first file, the first introduction is going to be an MZ on top. What? You put it somewhere? Where is the error? Oh, it's because it's open. All right, cancel it. All right, so let's debug it. So in the future, when you're writing big applications like loaders and implants, this part of Windows debugging is actually one of the best things that Windows gave us. So when you're writing your own applications and you can go through how the module is running, how it's being debugged, you can actually be able to learn a lot how Windows actually works. So we want to go to tools. Okay, the wait loader. All right, so it loads up the first part, and you can see from here the entry point for the car is supposed to be where the image dose header is, which means the current part of it, which is on this memory. You can always change this to hex. I think it's supposed to be changed here. No, how do you change it to hex? This one, I forgot. And you have the previous and also the other information about the win main. So right now, if you actually want to see the windows for debugging, so they're actually on memory, and what we want to do is look at the first way it actually calls it. So we go on top. Or you might have to look for it. So it's supposed to be here. So let's just copy it. Yeah, where it starts, and then we search for it. And this is where the MZ is, 4D, 5A. And you can see it's actually now automated, because right now we are looking at the assembly level of the whole debug. So right now, if you go to Windows, you go to assembly, and you'll notice how it's actually being called on assembly level, right? So yeah, so I think we posted a little bit for questions, so I'll stop, and that's a normal simple source code. So this is an executable. It's a PE file. So actually, if I open it with Cff Explorer like we did before, you can notice it's a 2-bit version. It has a dose header on top, which is 5A4D for MZ, and it goes all the way to alpha-new to connect to the other headers that a PE has. So any questions? All right, let's look at the questions, maybe in the message box, in the messages. I hope you're together on the whole thing, otherwise let me know if anyone is lost on anything so that I can go back to it.
Can I ask a question?
Yeah, go ahead. But don't go so deep because I'm asking about system by two, system enter.
Okay, my question is based. Okay, my question is based on the executable and the DLL. In what scenarios should one develop a DLL as opposed to an executable file? I've never really gotten it clear.
So something about DLLs is it's amazing because they can hide themselves inside systems. Okay, executable will always be seen. Like now, if I run this one, if I go to Process Hacker. If I go to Process Hacker and I look at it, it's called get path. I don't know if, oh, sorry, I'm not sharing. Sorry, I forgot. Let me share that up. All right, so boom, boom, boom. Where are we? Yeah. Okay. My screen is shareable. You can see it, right?
Yes, we can.
It's supposed to be get something. Where is it? Here it is. You can see it here as a process. But inside it, if you go to properties, if you go to modules, this is where you have the DLLs. So by default, the DLL will not be here. So if you find a way of dropping a DLL which will be run by another process, you hook it up here, maybe by DLL hijacking, or other maybe by other things like other ways that we use DLLs to actually hide. It will be here. So for someone to actually find it, they have to go through the process. Let's say you found a vulnerable HTTPD process, and you found that at a certain time. Okay, this is not showing me because I need to open it with higher levels of so if you go to properties like this one, with the DLLs, like now if you find a DLL here which is vulnerable, and this DLL, it can be replaced. That's one thing. You can replace it with your own DLL. Obviously, anti-DLL is a known DLL, so you can replace it because it's protected. It's a protected process. So there's something called DLL hijacking, other things like, I forget all those things. There's DLL hijacking, and so many other that you can do, whereby you actually impersonate a DLL so that it can be the first to be pulled by that process. So by default, when you're working the DLLs, which you're going to do right now, is that they don't run directly. They get hooked into other processes by injection into themselves, into those processes, so that they can run, they can help that process run. So if you're actually capable of doing this, like now let's say you fake a DLL, and whenever CMD is opened by an administrator, that DLL starts. That would be a very good implant, because no one will ever see it. It will just be behind there unless someone now comes to CMD is wondering, how many DLLs do I have here? Why is it one DLL, some of the DLLs are not signed by Microsoft? And that's when you'll know, holy shit, I have a bad DLL on my box. And that's how it goes. So when you want to make DLLs, it's because you want to hide behind other processes. When you want to make a normal EXE, it's because you just want to do a process run and you don't mind who finds it. And that's how you find most of the keyloggers being used by the African financial threats in Kenya and Africa. They just do a normal executable. Other guys usually do run the DLL directly via a command called run DLL, which we're going to use in a few minutes. Run DLL-2. Which actually runs the DLL directly. Like if you have the DLL here, you just do run, then the DLL name, then the export name of that DLL. So I don't know if you have enough time to do that, to make a DLL, so that now we can continue from that part to TBs and PEBs, so that can actually understand how those processes are ran on the background by the Windows imaging capability and loader. I hope I explained everything that you require. I hope I didn't go so deep to explain some of the things. But
yeah, you've explained it.
All righty. Any other questions?
Another one.
You know, man.
Hello.
Yeah, go ahead. If you have any other question, no?
You've displayed, when you've opened the DLL, we have seen a few base addresses. Do they change or are they fixed? Those base addresses, when you've opened the executable, you've opened the DLL from the executable and you've shown the, just open the executable.
Oh, this executable? This one? Oh, on the process?
Yeah, in the process, yeah.
Very good properties, and then you can see the DLLs, the modules that are loaded.
Yes, those base addresses.
Uh-huh.
These are the base addresses.
These are the base addresses for for where this DLL is running on the TEB level. Like now, do I do this right now or not? Do I have a WinDebugger installed?
Okay.
WinDebugger. No, it's not there. Let me start with debug so I can see what I mean. Although I was supposed to do it this time now. WinDebug, WinDBG, MSDN, MSDN. All right, download. Microsoft. Yeah, Windows has come up with so many tools that you can use to do some very bad things, and we enjoy them so much. Where's the download folder? Okay. I have to download directly from the Windows Store. I cannot download directly anymore. Okay. Let's see if it will allow me. I don't know if it comes with Windows SDK. I would never try to check if it comes with Windows SDK. It will take forever. Well, let's just download it directly from the store. Hope it will allow me to download it. Yeah, it is. It wants me to get directly so it can go to update. I wanted to have it on my folders, but it's okay. I don't have I don't have an account. How do I do this? All right, maybe there's only do it in my class where you work with Windows debugger, but by default, Windows debugger will show you how each base address for each process is mapped up in the process environment block. And you can actually be able to read them directly. I don't know if it will allow me to get, let's see, without a password or username. All right. Wow, it's allowing me. Okay. All right, let's wait for it to come down. I believe I have good internet connection. All right, looks like it take a while. What the hell? Oh, it's not that big. I thought it's a GB. It's supposed to come very fast because, yeah, 1.9, 2.5 MB, okay.
By the way, is it possible to, for example, if you want to write an application and you want to access that base address to either to read the values or to manipulate it, is it possible or what? Is it blocked?
Yeah, we should do that, but that's a different class because now if you start doing that and you start working with some functions here like NT allocate, virtual allocate, and stuff like that, it's going to go ahead into a roller coaster for everyone. And I just want to do an introductory class. I don't want to get to a point where everyone goes home wondering what the hell am I doing in cybersecurity.
Oh, that's okay.
Yeah. But I will do is if I get time in the course of the month, you're going to get to a point where you play around with some stuff. Like now, when you are doing things like what do you call it? Like now, when if I land this application, like this, what you have already ran, we have already made. I open it up. So new. Cancel this. As we wait for that things to download, and then we drop this there. But therefore, one thing we should hide. Oh, here's what I was talking about, the program database path. So to tell you, see the username. So sometimes people forget. It's always a good idea to actually maybe change your username to dev or developer, so that your username is not TRT, see users Gichuki, and people go, oh, it's jokes made it, and it's being used to hack equity. We know who you are. So don't do that. So the imports, as I was saying, whenever you're writing an application that you don't want, you want to give some headache to an analyst, it's important to actually make sure that some of these imports are not seen. So those are some of the things you're going to work with when we are hiding the imports. Forgetting how we call it, resolving, so that we hide how Canada 2 is resolved so that you don't see this function. You get it? Like now, Windows message box, you can always resolve it so that people don't see it when they're analyzing the application. So if you have very bad Windows API functions, which are going to be picked up by the EDR, you can hide them by resolving the function yourself, rather kind of directly, to actually avoid that stuff from being seen by the EDRs. So some of those things, I hope you're going to have time to walk all the way to antivirus evasion and EDR unhooking and all that stuff. So yeah.
We will allot enough time, because your topic was among the top requested topics, so we will prioritize on that.
Okay. All right, let's try to open WinDBG. Oh, because we can allow it. So I think we did open it with a higher collection. So what you want to do is that we want to open a file. Launch attach process. No, we want to open it. You don't have that anymore. Are you kidding me? Oh, launch Explorer. I think it will have that. It will work with that. These days they call it launch Explorer. Amazing. I'm still using the old one. So we are looking at CMD, where you have we have the yes, because it runs and it's running on debugging mode. So by default, it's going to tell you all that information. So if you want to see the whole, it's supposed to be like that, PEB. If you want to see the whole, no, it's not like that. So DT underscore PEB. Yeah, it is. So if you actually walk through all this, all the way from, where is that thing I'm looking for? The image-based address, which is actually pointing to, it's actually pointing to actually going to the LDR, which is pointing to PB LDR data. You'll be able to read the, the base address. So what you do as an answer, but I hope I don't confuse anyone here. So I'll just make a simple ways of actually doing it. Let's say you already made a pivot structure that's going to carry that information. So let's say we call it from somewhere, maybe this for mostly for another class when you're writing loaders from somewhere, and then we specify, let's say, what are you going to call it? Let's say we are going to look for the image-based address and so that we can load it up for Canon. So for Canon, that is 2 DLL. I'm sure for those guys who have done what you have done analysis for malware and other implants, I think you have noticed some of these things. Alrighty, so obviously this one have to be done on command line level. So I'm not going to go deep on this right now, but when we finish Windows debugger next time, this is going to be very important for us. So like now, you might need to play around with the exe so that you can call stuff like what do you call it? How the entry goes, which is supposed to be, what do you call it? The 0x3, I think suppose x3 for FS. This is for 64-bit. Yeah, for the 2-bit is FS. This GS and FS. Okay, I'm going to confuse people. Let me not talk about this right now, because this one requires that we do what we call Windows debugging. This for another day. All right, any questions before we go to the DLL? Before we go to DLL, any question? I think it's already 1950. We're out of time. People want to go and do a BG of Peacemaker. It's out for the episode. All right, DLL of get path for DXE. So this one, you're going to build it to actually be able to see the command that you're going to use when you run the DLL. So as usual, if you want to make another solution or another project for the solution, you can go right click here, and you want to click it goes to add, then you go to new project. Then on new project, you just go ahead and do the empty like we did before. And this time we call it, we call it get path for exe or get path for launcher DLL. Then the proper get path for launcher DLL. Oh, yeah, good. So as usual, we want to make a CPP file here. And we add a new item. So before we go to a different class, make sure that anyone who want to go that class has been able to do this. Because if you can't be able to do some of these things, it will be hard to do the other classes. All right. Let's just call it the same name you're using for the solution. So as we saw from Carbonac, they use bool API entry DLL mode. That's exactly what you're going to do also. So as usual, include Windows API, Windows H, and we do the entry. And the entry, obviously, because the DLL, I need to do what you call process attach to attach the process or process detach. So we're not going to add more stuff on the DLL attachments because it's a simple class, it's a beginner class. And so because of that, because it's trying to see yes or no to whether it's going to attach it, we are going to use bool. So by default, the entry is going to be not an int this time. It's going to be a bool. So API entry, sorry, supposed to be 1.1, API entry. And obviously, what you saw from MSDN and also from Carbonac is what we call DLL main. So as usual, we're going to now call the H instance or the H module. So H module. And this time we're going to call it base. Then there's supposed to be a call for DWORD, I think. You can always point here to actually know where you are. And you can see that's what it's actually telling it is a normal SDD call. Those are things that are actually amazing me sometimes. DWORD let's say a call and a local point for the parameters that you're going to use for that. So if you want to see how a DLL looks like, you can always go ahead and do MSDN DLL main, and it will take you to the information desk for DLL main entry, and you tell is an optional entry into dynamic link library DLL when the system starts automating the process. So by default, it's supposed to attach to a thread or attach to a process. Like we said before, when you're looking at the processes that CMD was running. So they're attaching themselves, and if they're not being used, they detach themselves, right? You get it now? I hope you get it now for what you're doing. I know when it comes to DLL, for anyone who is beginning on it, he gets lost on this stuff. But that's how a DLL is supposed to work. So on deeper level, when you go to things like DRV, we are going to look at further innovation, what you can use with that. All right, so any questions so far? We are like 7:54 minutes. All right, let's do the detaching. This one is going to use what you call a switch. So I think here they specified that. So you do a switch, performs action based on reason for calling that DLL. And by default, the reason should be on your DWORD. So mine is going to maybe I call it a call. I call it a call here, which is this. Then also we specify the DLL process via the switch. So if you have done case and switch, it's going to be very important for you in the future, because that's how we're going to be writing our DLLs. And then here you can return true. So by default, let me make sure that we have returned true here also, so that we know that the DLL is being executed. Also remember that every time you're writing C and PHP and any other C level language, you always close it with a semicolon. So yeah. All right, so let's do a switch to actually now do the DL, how the DL is supposed to be processed. It's supposed to be ran. So switch, and what you're going to call is this call, the DWORD. So the reason for calling it, it's call. And down here is where you specify the cases for the reason why you wanna attach, or how you wanna do the cases for attaching and detaching. So by default, you're going to start with the case for DLL process attach. All right, so the other case is for case DLL process detach. All right, so because these are cases, by default, we don't close them in semicolons. We should close them with a colon itself. So right now you can see there is no more error, because every time you make an error, it will actually tell you, Visual Studio actually tell you that you have done something. So always make sure that your errors are not there as you write code. And then we break with a default. As usual, column, and then we actually specify that we want to break from this, and so by default, when you open a switch, you're supposed to showcase you've opened it. So break. All right, save. So by default, this is going to be how our DLL does the entry, so that you can execute the exported function that you're going to give it, which is going to be a DLL export function. All right, so what you're looking for is maybe something like what we just did before. We get file name. And also something can do, we can also add other things like the name of the computer and stuff like that, just like the way DLLs usually, like the way we usually play around whenever we are making stuff to do with the implants. All right, any questions so far? We do the external. All right, so where is it being called from? Just like we did with this other one, with this other function for get module. So what I'm going to do is that I'm going to put the extern for this call, which is going to be C level, and we are going to describe it. So DC something spec, yep. And we are going to specify that you are doing a DLL export. And here we specify the export function you're going to use. What did you call ours here? What did you call the function for calling the entry? Let's just call it the entry. So the DLL entry. So yeah. And this is where we are going to specify how we are going to actually call the which one are we using? Get module file name. Yeah, get module file name. So as usual, just the way we did it here, I'm going to go ahead and specify the same thing. So I'm going to copy this and I'm going to put it here. Have we done it properly? So get module size of where, DLL entry, +1 for the path, the message box. We are running it from here. So this is one, and you got it. So let's save it. So the other thing is that right now we are dealing with a DLL, which is a Windows system project. So we need to go to the project and go to the properties, and we need to go to general and specify that what you're running right now, what you're compiling, is a DLL. So down here, we need to make a few more changes, like on the linker on the system, it goes ahead and specify that what you're running is a Windows application. So apply and OK. And now if we compile, so by now you can see we have two projects, and you can see this one is actually in bold. It's because it's a startup project whenever this application is run. So you can always change and put this as a startup project, but it doesn't matter. So what you can do is maybe, because you don't, not a must to do that, you can always build, or can always build this directly by running build. And if all goes well, we should have a DLL that actually calls get module file name, and it can give us the path from where it's being called from. And there it goes. So let's go and see whether we can run it. So by therefore, remember, we have the entry point, other the exported function. So to see it, you can always use either as usual. So it's supposed to be here using a debug. We can drop it on either, so you can see the export. Either drop the DLL, and also let's lay it a tool file. It tells you the whole path for the PDB, and as usual, you can see the export, which is actually the entry point, which is a DLL entry, like what we just did with the entry point here. Alrighty. So I mean the export here. So for entry. So now we'll go furthermore on this later on. I don't want to go deeper into how you actually look on those functions DLL in using here. But now let's execute this DLL and see whether it's going to run as we presume. So CMD. So to run the DLL, we do the command I talked about earlier, which is run DLL 32, and the file name, which is get path DLL, and then the entry point. The entry point is the DLL entry. I have so many CMDs I even forgot. And then specify it here. And then you press in, and it actually executes and tells the path from where the DLL is being executed to run this DLL. All right. So right now, if we go to Process Hacker, and we look for run DLL, this is what actually Cobra Strike does. So if you hunt for Cobra Strike and you want to find a DLL that's being executed for the keylogger, the DLL is being executed for maybe an implant that has already been done, you can look at this run DLLs projects, and to tell you the one. What? I have two of them running. Amazing. If you go to properties, you'll see that DLL we just made. Where is it? No, I'm on the wrong one. Okay, properties. Yeah, it is. And you'll get a path. And if you go to properties, you can actually unload it, or even go to properties and see where the path name is, and you have more information about it. So yeah, so from the next class, if we do it, we are going to go all the way to PEBs, and also this part I was explaining, I'm going to explain it further so that you can understand how do you read the kernel DLL when you're executing a file. Because by default, whenever a file is executed, the first DLL that's executed is NT DLL, which I didn't want to go deeper into. And then the next one, which is called this kernel .2.dll. And these ones are usually arranged in something called a double linked list. Which we can actually look at when we do we work with Windows debugger. All right, I think that's it. Unless there's any question or anything you need me to write here so that you can actually be able to get where we're going. Any question? Anyone? Nothing? So when you hear that a dropper is being dropped from a fish and it's dropping something that's loading on the system, these are some of the things that drop and run on the system, depending on the attack for that scenario. Yeah. So next week, when we meet up again, we are going to go deeper into PEB. But what I mean PEB is where we are going to see all this stuff, because you're going to be working with the LDR and also the PEBs is for the process, and also the TB, which is for the threads for each process. Yeah. Any question? And that's the beginner level for people who want to go to RTO and CNO. You have to have those on the baseline, right? Because you need to be able to write several languages, because but the main language to understand is the C, C++, and PSM. So you need to have a lot of work to be done with your classes, and a lot of training and practice, and a lot of research. Any questions? I don't see any. That's it. It's 8. And we go enjoy ourselves for the weekend.